Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at the standard equation for the hyperbola in grade 11. We know that the natural hyperbola has the equation y is equal to 1 over x. And the properties of this hyperbola is that it has a vertical asymptote along the y-axis and a horizontal asymptote along the x-axis. This hyperbola lies in the first and the third quadrant. We then learned that in order to manipulate the shape of the natural hyperbola, we can use the equation y is equal to a over x, where if the a value is positive, it will lie in the first and third quadrant, and if the a value is negative, the function or the hyperbola would lie in the second and the fourth quadrant. We then went on to learning how to vertically shift this hyperbola, and that was done by manipulating horizontal asymptote. In order to quantify this type of manipulation mathematically, we use the equation y is equal to a over x plus q, where the q value is the value of our horizontal asymptote. So in order for me to sketch it, I'm just going to do a little sketch here. My new horizontal asymptote would be somewhere here if I'm shifting it upwards, and my hyperbola would lie in the first and third quadrant or the second and fourth quadrant. And as you can see, guys, the only thing that has been manipulated in this function, in this vertical shift, is the value of our horizontal asymptote. In grade 11, we learned that we are able to manipulate the position of this function with regards to the x-axis, meaning we are able to horizontally shift this function. And that was done using the equation y is equal to a over x minus p, where the value of p is in fact the x value of our vertical asymptote. If I was to sketch that in, it would look like this, where the x value of this vertical asymptote is the value of p. And substituting that into the formula, we would have to put p into brackets. So for example, if this is positive 2, that would be a over x minus positive 2, and negative times positive would result in a negative, which would become a over x minus 2. If I were to have a vertical asymptote on the negative side, or in the negative x region, so let's say it's here, and let's say the value of the x value of this vertical asymptote is negative 3, right? In order for me to quantify it mathematically, I would substitute negative 3 in for p, and that would become a over x minus negative 3. Minus and negative 3 when expanded would result in a positive 3 value, and the equation would become y is equal to a over x plus 3. We also know that in this form we are able to identify the type of manipulation that is occurring. For example, here if it was shifted to the right, we would have an a over x minus value. If we were shifting to the left, we would have an a over x plus value. Right, so we can identify two things from this type of equation, and that would be the value of our and that would be the x value of our vertical asymptote and the type of shift that is occurring. Now, my question to you guys is, how do we combine all of these manipulations into one single standard equation that we can use in order to define any hyperbola, no matter what type of characteristics it has? In order to do this, we would combine all the types of manipulation that we have for the hyperbola, and it would result in us obtaining the standard equation for the hyperbola, which is y is equal to a over x minus p plus q. And if we identify the properties and the type of manipulations that occur in the standard formula, we would see that it encompasses all the types of manipulations that we can do for a hyperbola. Let's look at it. Y is equal to a over x minus p. The a value in this equation is the type of shape. If it is positive, first and third quadrant. If it is negative, second and fourth quadrant. Over x minus p, the p value would give us the x value of our vertical asymptote, and the x minus p, when we look at it, we are able to identify what type of horizontal shift is occurring. Furthermore, in this equation, we have a plus q, which determines the y value of our horizontal asymptote, or the type of vertical shift that is occurring for the hyperbola. It's quite simple, guys. That's it from me. All the best, and I will see you in the next one.